Hello everyone, welcome back to my YouTube channel. I'm Ananya, currently pursuing my bachelor's degree in Sri Venkateshwara College of Engineering in the Department of Computer Science and Cybersecurity. Today I'm here with the topic called Mathematical Induction. Introduction to Mathematical Induction. Mathematical induction is a powerful proof technique used in discrete mathematics to show that a statement holds for all natural numbers. This method involves two main steps: the base case, which establishes the truth of the statement for the smallest value, and the inductive step, which shows that if the statement holds for an arbitrary value, it must also hold for the next value. Together, these steps prove the statement. Next is base case. The base case is the initial step in a mathematical induction proof. It involves proving that the statement is true for the smallest value of the parameter, typically n is equal to 1. This step is crucial as it provides the foundation for the induction process. If the base case is valid, the proof can proceed to the inductive step. Without a valid base case, the entire proof falls apart. Inductive step. In the inductive step, we assume the statement is true for an arbitrary value, k, known as the inductive hypothesis. We then show that if the statement is true for k, it must also be true for k plus 1. This step establishes the pattern needed to extend the truth of the statement from one value to the next, thus proving the statement for all natural numbers. Principle of mathematical induction. The principle of mathematical induction asserts that if the base case holds and the inductive step is valid, then the statement is true for all natural numbers. This principle is fundamental in discrete mathematics and underpins many proofs. It is widely used to demonstrate the properties of integers, sequences, and other discrete structures, making it an essential concept for students to understand. In this slide, let's prove a sum formula. To illustrate mathematical induction, we prove the sum formula for the first n natural numbers like 1 plus 2 plus so on plus n is equal to n of n plus 1 by 2. For the base case, we check n is equal to 1, showing that 1 is equal to 1 of 1 plus 1 by 2 is true. The inductive step involves assuming the formula holds for some k, then proving it. Strengths of mathematical induction. Mathematical induction is a rigorous and systematic method of proof, making it particularly useful for proving properties of sequence and sums. It allows us to establish patterns and generalize results for all natural numbers. Its systematic nature ensures that each step logically follows from the previous one, providing a clear and reliable proof technique. Limitations of mathematical induction. Despite its strengths, mathematical induction has limitations. It may not apply to all statements, particularly those without a clear base case or well-defined inductive step. Induction proofs can be challenging for complex statements that do not follow a straightforward pattern. Understanding these limitations is important to apply the method effectively and recognize when alternative proof techniques. Variants of mathematical induction. There are variants of mathematical induction including strong induction and structural induction. Strong induction allows the inductive hypothesis to assume the truth of all previous cases and not just the immediate predecessor. Structural induction is used to prove properties of recursively defined structures, making it a powerful tool in computer science and other fields. that deal with complex recursive data types. Applications of mathematical induction. Mathematical induction is a fundamental tool in computer science, particularly for proving the correctness and performance of algorithms, especially those involving recursion. It verifies the properties of data structures like trees, linked lists, and graphs, ensuring they behave as expected. In number theory, induction is used to prove properties of integers such as divisibility rules and mathematical induction is a fundamental proof technique in discrete mathematics, providing a systematic way to prove statements for all natural numbers. Understanding and mastering induction is key to working with the discrete mathematical structures, sequences, and sums. It is a powerful method that underpins many theoretical and practical applications in mathematics and computer science. Thank you.